Hello all, welcome to the video lecture series for the subject Database Management System. Today I am going to explain you all about the normalization and its techniques in database management system. Basically, normalization is a set of progressive rules and for a relational scheme that reduce redundancy and prevent data anomalies. This is the actual scenario for this normalization. So here you can check, that is, a normal forms are a set of progressive rules and the same form which is used to reduce the redundancy, right? So the second step explains you all about the each normalization form is very stricter than the previous one. Say for example, it starts with 1nf and ends with 5nf. So we have normalization 1 form, normalization form 2, normalization form 3, bcnf, 4nf and 5nf, right? So one by one we are going to check how this normalization form 1 to 5 enables the redundancy technique in database management system, right? So we'll see some benefits by using this normalization form. Number one, it reduces the duplicate data and the vast storage. So basically it is going to prevent and it is going to reduce the duplicate data in the table, and each table represents and performs very effective when this duplicate data has been reduced, right? Second most important thing is it is going to prevent insert, delete, update anomalies in a particular table, right? So one by one we are going to check the third important point. Here it is going to improve the data consistency and integrity in any table format in a database management system. So here all these three plays a very important role, and finally it make the schema easier to maintain and evolve. If you use all these three benefits, and the normalization form make the schema very easier to maintain and evolve. So let me take you to the first normalization form. So here it is. Now the first normalization form, it always enables all columns should contain atomic values. The meaning of atomic values, there should not be more than one values in a particular row, right? So we are going to see that with one example that is actually called an atomic value. Each row should be unique and each column has a unique name. So this is the basic criteria about first normalization form. We are going to check that with one example, and this example is going to work with simple form of 1nf, right? If a table has a column, that is a phone number, you all know a particular person can have multiple phone numbers. So that is the reason I have taken this. So that stores multiple phone numbers in a single cell. It violates 1nf. I already told you all columns should contain atomic values. That means any column, a particular row should have only one value. It should not have more than one value. That is a point here. So we have taken this process as an example. So this process is actually violates the 1nf. Let's check how it is going to be a 1nf if a particular table exists. To bring it to 1nf, you need to separate phone numbers into individual rows. That is a point. Now you can see here, this is a course table, right? And this is a course table 1 and 2. So I have taken different example here. So here the example I have given explained you about the phone number. Let's get into the course table where a student and table column which always relies on this database management system, and it is also very easier for us to understand. Now for example, the course table have ID of the course, name of a particular student and course of a particular table. Right here ID always resembles different, that should be unique. Name we cannot assure it should be different, and course also. Now you can check ID1, the name of that particular candidate is Vino, and the course I have taken as C1 and C2, that is course 1 and course 2. And ID number 2, which have a different name, that is Vinny, and the course she have taken as C3, and number 3 shield, and she have taken C2 and C3. A particular name can take multiple courses, as you all know as a student, right? So this is actually before 1NF. I told you already, this column should be an atomic, it should contain an atomic values, right? That means there should not be more than one value in a particular column. So to make this as a 1NF, here it is the process. Now you are going to repeat this particular ID and you are going to repeat the name, and there is no repetition in this particular row in a particular column, right? So we know adopted C1, we know have C2, we have C3, she'll have C2, she'll have C3. So this is before 1NF, this is actually the after 1NF. So we have made this particular column atomic, that is there is no values here in a particular column, in a particular row. It has been it has been repeated with more than one course, right? So this is how this normalization form 1 exists with a particular database, right? So let me take you to the second normalization form, right? So now we are going to see one by one how exactly this forms, that is second normalization form, exists and how it is helping a database to reduce the redundancy. So here it is, the second normalization form, right? So it is based on the concept of fully functional dependency. We are going to see a new concept here, the dependency format about a particular column to another column in a same table, right? So here you can see all column contain single and indivisible values, as we did in the same process with the 1NF, right? So there should not be any repeated values in a one particular row in a column. So there is no repeating groups of a columns, right? And it should eliminate partial dependencies. We are going to see how this dependency works with one particular example for 2NF, that is second normal form in normalization. Now you can check, this is the first example I have taken, the same course table I have taken, right? Now you can check, this is the student number, this is the course number and fees, right? Now a student number, that is 1, right? It is repeating twice here. You can see the course number. The student can take multiple course and the fees may differ. Okay, so now we are going to see that how this particular table can be reduced into non-redundancy form, right? So in order to do this, say for example, student numbers is always depends on course number, and this course number is always depends on fees, right? Now there is a partial dependency here. So we are going to reduce this partial dependency, that is between the course number and fees. There is no partial dependency between student number and fees. So it is decided to separate this course table into two different tables. So we'll see the table number 1 here, right? Now this table number 1 here, you are going to check that we have separated student number and course number here, right? Why? Because student number and course number have dependencies with each other. Now student number 1214442 has been separated with this course number alone, right? And in order to reduce this functional dependency, that is this fees should not depends on the student number, that is the primary attribute. So in order to reduce this, we have separated that into different one. You can check it here, right? So here it is the form, this course table we have created, course number and fees. Now course number 1, 2, 4, 3, 5. Now this column, there is a redundancy before because C1 has been repeated twice. You can see here C1 repeated twice here and C1 repeated twice here. So in order to reduce that form, we have reduced C1, C2, C4, C3 and C5. There is no repetition here. As well as here in the fees, there is no repetition in the fees. 1000, 1500, sorry, 2000 and 1000. It depends on the course, right? 1000 here and 2000 here, right? So this may get repeated values, and this repeated values is partially dependent before, that is in the course table, that is in the main table. But here, after this applying this 2NF, this partial dependencies has been eliminated with this, with this separation of table. That is, we have separated initially student course table, and after we have separated the same course table into course table here, right? Two different tables. This two different table enables 2NF, right? So there is no partial dependency, that is eliminating the partial dependency. Initially there is a partial dependency here between the student number and fees, course number and fees, student number and course number. So in order to reduce this particular thing, we made that into two different table. This two different table enables 2NF, right? So here comes the after format and here comes the before format of this particular database. I hope you understand this 2NF, right? So this is the table dependency here. You can able to check, right? Let me take you to the third normal form, right? Right. So this is going to be interesting because first two normalization forms we have studied about, we have observed about how exactly the database is going to be a non-redundancy form, right? Here you are going to check. See here, it builds on this 3NF is actually builds on 1NF and 2NF. In order to enable this 1NF and 2NF, 1NF you all know that it is atomic value, 2NF there is no partial dependency. We are going to make this together to build 3NF, right? So here what this 3NF ensures that the database structure is free from transitive dependency. That means a column have more than one dependency in a same table, right? Partial dependency in the sense one column in a table can depend on another column, not more than one. But here transitive dependency in the sense if any of this table column depends on one prime attribute, okay, that is going to be a transitive dependency. Let's take it one example. I'm going to make sure you are going to understand this table, that is a candidate table, and we frame this for easy understanding, right? So now here you can check candidate number, candidate name, candidate state, candidate country, and candidate age. So here there is a prime attribute, okay? The prime attribute here it is candidate number, and you can check that it is candidate name is depend on number, candidate state is depend on number, candidate age is depend on this number, okay? Candidate country can be same, so it is not dependent, it is actually dependent on state, okay? So here more than one more than one column is actually dependent on one particular non-prime attribute, right? This is non-prime attribute, this is a non-prime attribute, and this is also a non-prime attribute. We have only one candidate key, right? That is candidate number, right? Because it identifies uniquely on all the other all the other number of columns, right? So this is actually before. Let's see how it exactly converts into the next 3NF. This is actually before, right? So I told you about how this the columns is actually depends. Now we are going to see how we are making this into 3NF. So here it is 3NF. How it is going to do? We have separated this table into candidate table and state country table, right? Now listen, now there is only 3 rows here and 4 number. I told you already, whichever column is actually non-transitive dependency, we are going to separate that, and transitive dependency separately. So here you can check candidate number, candidate name, candidate state, and age. right? So here candidate number ATN Tamil Nadu 20 and age is 20. Here it is 21 West Bengal, candidate name is B. So that is unique here. Candidate number is unique. Candidate name may be unique and candidate state may be unique, and this is also may be unique. So here there is only one candidate key. All the other columns are dependent on only one candidate key, right? This is actually prime. Okay, now we are going to separate the non-prime attributes, that is here. This is non-prime attributes. The state can be repeated, right? One candidate, all in a class, for example, 60 students are present, 20 students may be from the same state. Okay, so that's why it is called as non-prime attributes, that is candidate state. All the students from the same country, very few from different other country. So this is also non-prime attributes. We have actually separated prime and non-prime attributes separately, and here you can see the difference. So here we have reduced number of repetition, that is West Bengal into 1 and TN only 1. So both of these states depends on the country, that is India. Now India's countries depend on state and state is depend on this particular process. Only one dependency here. I hope you understand how this 3NF is actually made, and I'm going to continue the same process with other three different NFs, that is normalization from, that is bcnf, and then 4NF, 5NF and 6NF in my